Hi guys, today I'm going to talk to you about acids. Before we begin, make sure you have a highlighter, a pen or pencil to write with. You will also need your polyatomic sheet that you guys got. It is a reference, so make sure that you guys keep it in a safe place. You should refer back to this as much as possible. Don't forget you do have some ions that you need to memorize, and those ions will definitely not be available to you on the test. So do some work and memorize those ions, okay? You will also need a periodic table of elements, so any periodic table will really do, okay? So let's get started talking about acids. Okay, so an acid is a compound that starts with the letter H, okay? And that's really important. So an acid is a compound that starts with the letter H. That means, let me get this in view, that means that the hydrogen is a plus ion, and it is connected or bonded to a negative ion. So in other words, you have hydrogen, that is a cation, and you have X, whatever that X value is the anion, okay? This is the positive, this is the negative. Usually keep in mind that your cations are your metals and your anions are your non-metals that you have on the periodic table. Okay, so let's get started with acids. Acids fall into, the naming or the nomenclature of acids falls into two categories. The first category is known as binary acids, and the second category is known as ternary acids. Now, the difference between these two is that binary means two, so binary acids really just have two letters usually that are involved in it. Ternary acid is now three or more values or three or more letters that are involved with an acid. Usually a ternary acid also means that there is a polyatomic ion, okay? And keep in mind that most of your polyatomic ions all have gases that are attached, all have oxygen that is attached to them. So ternary acids always have an oxygen attached to it, and that's why you use the polyatomic ion chart, or this table right here. Okay, so moving on. Binary means two, and usually you have two values or two variables here. The first variable, as you know, is always going to be H, that's going to stand for acid. And then you're going to have a second variable, and that second variable is going to be anything it's usually an anion that has a negative charge to it. And the anion is almost always found on the periodic table. So if we use our periodic table right here, zoom out here a little bit. Okay, looking at my periodic table, all of this, so your metalloids are right here, but anything below the metalloids is a metal. Anything that's above the staircase or your metalloids is a non-metal. So the anions that I'm talking about are going to come from here on the periodic table, okay? This is the red group that I have highlighted. That's where your anions for a binary acid are going to come from, okay? So, so the prefix for a binary acid is hydro, and the suffix is usually IC or ic, okay? A ternary acid, on the other hand, you have once again the H that is there that represents the acid, so you have the H plus, but keep in mind that there is no prefix, unlike you do for the binary. There is no prefix. You are directly using just the polyatomic ion. And depending on which polyatomic ion it is, the prefix of that acid will change. If you have an ATE ending of a polyatomic ion, the ending for that particular acid will be IC. If you have an ITE ending, the ending for that, and ITE is the ending for your polyatomic ion, the ending for your acid will be OUS. So what am I really talking about? Well, look at this. ATE and ITE, well, those are the endings of your polyatomic ions. So if we happen to just look at phosphite and phosphate, notice how phosphite has an ITE ending. And let me zoom in right here. Phosphite has an ITE ending. If it has an ITE ending, you're going to replace the ITE with an OUS ending. The ending for phosphate is ATE. So that means you're going to replace the ATE with IC ending. Okay? So these are just a couple of rules. Let's go ahead and try naming some of these acids. This is hydrochloric acid. Okay? Notice that for hydrochloric acid, you've got the word hydro in front of it. Every acid, as far as the naming goes, you will always have the word acid behind it. Okay? And whenever you are writing the formula for the acid, you're always going to have an H in front of it. Okay? So since this has, for naming, since it has the word hydro in front of it, it is now a binary acid. So it's a binary acid. That means that the first, and because it's an acid, the first variable that you're going to write is going to be H. Okay? So it's going to be H right here. And then chloric, since it's got the ending IC, well, the element that it is talking about, chloric, the element itself is chlorine. And you can see it in the word itself. So, and chlorine definitely is an ion that is in the red area of the periodic table. So it's right here, chlorine. So keep in mind that hydrogen has a +1 charge. Chlorine, keep in mind, has a -1 charge. So we're going to write chlorine minus. Okay, and now we're trying to figure out how many atoms of each. All acids are neutral, so they're going to have a charge of 0. So you're going to have here, and let me grab a different color pen so that you can see this. So you're going to have 1 times 1 plus 1 times 1 minus will equal 0. So since the number of atoms for hydrogen in chlorine are 1, we don't need to write that 1 down there. Okay, so it's just HCl. Okay, now let's go ahead and answer number 2. This is perchloric acid. Well, the first thing that you notice is that it does have the word acid. So for the formula, we're going to write our H there automatically. Secondly, notice that the word hydro is missing over here. So you don't have that prefix. If you don't have that prefix, that means that it's a ternary acid. That means that it's going to have 3 or more variables in it. So you've got perchloric acid. So we've got our hydrogen. There's no prefix. So, and notice that it has an IC ending. IC ending means that perchloric happens to be the polyatomic that has an ATE ending. So it's perchlorate. And if you look at your polyatomic chart, okay, it's right here. It's one of the halogen groups. So this is perchlorate. and the ATEs here? Well, the formula is ClO4 minus 1. Okay, so this is ClO4, and it's got a minus 1 charge. Hydrogen always has a plus 1 charge, so we're trying to figure out how many atoms. So in this case, it would be 1 to 1. Okay, and keep in mind also that all acids, again, you guys, always equal 0 because they're completely neutral. Okay, so acetic acid, again, realize the word acid is there, so we're going to put an H over here. And then acetic, it has an IC ending, there's no prefix. So we're going to go right here, IC means ATE. We're going to go back to our polyatomic chart, and it's probably acetate. And let's see what the formula for acetate is. Well, here's acetate. It's got ATE, and this is the formula. You can use either one of these formulas. I'll use C2H3O2 this time. So C2H3O2. Okay, and if we're interested in doing the charge, then we can do the charge for it. Acetate is a 1 minus. Hydrogen is a 1 plus. Adding these. And of course, we're going to need 1 atom of each. And we don't need to write 1 over here for either one because that is completely understood. Okay? Let's go on to the next one. This is phosphorus acid. Again, it's got the word acid, so the first thing we're going to write is our H. And then it's got OUS. Doesn't have the word hydro in front of it, and because it doesn't have the word hydro, it's not binary. It is ternary. It's got no prefix, but it's got an OUS. And that means that the polyatomic phosphorite, let me bring it to your view. Let me zoom out a little bit so you can see. Okay. So it's got an OU ending. It's not a hydro, so it is ternary. And OU ending means it's ITE ending. That is the ending of the polyatomic ion. So this is phosphorite, ITE. So if we go on the periodic table and look, it's right here, phosphite. Okay? And remember, your polyatomics are a little different when you say them and when you write them. You're not actually writing the name of the element phosphorus, but it's going to be a little different. So it's phosphite. Okay? And, well, look at this. It's got the formula PO3, 3 minus. So, PO3. Now, phosphite has got a charge of 3 minus. Okay? And hydrogen, again, has a charge of plus 1. So when you start adding all this up, you get 1 phosphorus or phosphite ion, and you get 3 ions of hydrogen. So now we're going to end up putting a 3 right here. Okay. The next one, you guys, again, it's hydrofluoric acid. First thing you should notice is that you've got the word acid, so we're going to put our H down. And then now we do have a prefix. It's hydro. So that means it's a binary acid. If it's a binary acid and it's got an ic as a suffix, so we're good to go on that. That means you can probably find this element somewhere on the periodic table. And so when we start looking at our periodic table, it's an anion. So we're going to look at the anions right here. They're right here, the anions. So fluoric sounds a lot like fluorine. So we are going to actually write the symbol F right here. So keep in mind that fluorine has a -1 charge. It's always equal to 0. Hydrogen has a +1 charge. And when you add it up, you have one atom at each one. Okay. Our last one is hydrocyanic acid. Now this is the exception to the rule, so put a star right next to it, because, and you'll find out in a second that this is by all means a binary acid. So you've got hydro right here, and you've got the word acid, so we're going to write that H down, and hydro is right here. So it is binary, but it is cyanic. Okay. Well, that cyanic is actually a polyatomic ion, and it exists right here. It's actually called cyanide, but notice that it has an IDE ending. So IDE ending is actually the ending that you have for all of your ions. So all the ions that are on this periodic table right here, you know that they all have the same ending, which is IDE. It's fluoride, chloride, bromide, sulfide, nitride. So when these nonmetals or these anions, when these nonmetals become anions, they take the IDE ending. So cyanide is just the exception to the rule. Even though it is a polyatomic ion, it still behaves as a binary acid. So notice cyanide is Cn. So we're going to go over here and write Cn, because you need them both. And then, to find out how to completely write a formula, cyanide has a 1 minus charge, and hydrogen has a 1 plus charge. And they're both going to be 1-to-1 ratio. Unlike phosphorus here, it was 3 hydrogens for every ion of phosphite, I should say, right here. Okay, so this is naming acids. Let's talk about how to write the formula for acids. Now the formula is also easy. So we're given the formula and we want to write the name now. So we want to do the exact opposite of what we did here. We were given the names and we wrote the formula. Now we're given the formula and we want to write the name of each one of these. So right off the top, we know that this is an acid we're dealing with because you have an H in front of it. So you have C2O4. Well, keep in mind, you guys, that this is, first of all, it's got an oxygen, and it is 3 or more elements. So 1, 2, 3. So this is definitely not a binary, but this is a polyatomic ion. So we don't put a prefix. This is, and we need to find out which, what is the name of the polyatomic ion here. Okay, so we're going to go to your polyatomic chart. We're going to find it. And when we do, we realize that it is actually this element right here, this polyatomic ion, which is oxalate. And it is C2O4 with a 2 minus. So we're going to write here, all right, with this one. And because, realize you guys, because it has an ATE ending, we're going to give it an IC ending. Okay? Oxalic acid. Okay? The next one is definitely, you can tell that it is binary. So that means we're going to have the prefix hydro in the front. And then the name of the anion right here. Well, this is actually, according to your periodic table, this is actually sulfur. Right here. So instead, we're going to write hydro, sulfur, and remember my suffix is IC, sulfuric acid. Okay. The next one, you guys, is, again, it is an acid, and notice that it is a polyatomic because it's 3 or more elements. and this has got an oxygen group attached to it, so it's PO4 3 minus. And if you look under the phosphorus group, this is where the element is. It is actually phosphate, PO4 3 minus. So it's phosphate. Okay, so we're going to call this, the 8 becomes ic right here. And again, you guys, you want to experiment with the spelling as much as you can, but really sometimes it's just spelled the way it sounds. So this would be phosphoric acid. Okay. The next one is, again, it's got a hydrogen, so we do have the word acid attached to the end. But now, again, you guys, this is ClO. Okay. First of all, that is not a binary. It's more than 2 elements. It's got the oxygen, so we know it is part of ternary, and it is more than 3 or more. So, and that's what happened, that we have 3 or more elements in total here. So you're going to look it up on your polyatomic chart. The ClO, what is that called? So if we look it up on our chart here, we'll find it in the halogen group. And if we look at it, it is ClOs right here. It is called hypochlorite. Now it's got an ITE ending, so we're going to replace that with OUS. So this is called hypochlorous acid. Okay, OUS acid. And okay, so the next one is once again a polyatomic. It's ternary. You're looking at NO2. NO2 happens to be part of the nitrogen group in your polyatomic chart. So it's NO2, that is nitrite. The ITE will be replaced by OUS. So this will be nitrous acid. And then finally, last but not least, we've got our HI, which is clearly just two elements. So it's a binary acid. And so we're going to put the word hydro in front. And then you're going to write the name of the anion. In this case, it is iodide. So this would be hydroiodic acid. Okay. So, and notice that I put an IC ending, and it's an IC. Okay. So this is a good review, just to help you understand and remember the endings. This is a good mnemonic, but it is my ride, IDE, has hydraulics. So this would be for the binary. Okay. This would be the binary acid. And then it says, I ate something icky. So I ate something icky. And then Sprite, ITE, is delicious. And of course, both of these are part of the ternary acid. Okay. Which means that usually your anion is a polyatomic ion that's found in the chart. Okay. I hope this helps you understand acids and how to write the formulas and how to write the names, the name of the acid. Okay, guys, see you later. Bye.